Hello, welcome to our UCE math practice, and today we are dealing with changing the subject of a formula, okay? And these are our nice 6 questions. This part is simply to do with arrangement, so that means we are going to do to learn how to move terms, and when we say making the subject or changing the subject, it simply means having a term left on one side of the equal signs. Like when I have this is the subject in this formula here, t is the subject, n is the subject, okay? And so we are taught to make different unknowns to be the subject, or to express certain terms as the subjects in a given formula, okay? So here we go with our first question, question 1, where we are told make A the subject of the equation. And so that means we need to rearrange it and make sure we have A left. Usually we put the term which has been made to be the subject on the left hand side of the equation, okay? That's how we usually do it, but it can also be on the other side. All right, so when we look at this, we see a squared. There is a term up here. We also have a term down and another a term here. So that means we need to find ways of putting the a terms together, okay? We need to find ways of putting the a terms together. Starting with the denominator, we see that we have more a terms in the denominator. This denominator here can be simplified in the form a squared minus b squared. This is an identity that is known as a difference of two squares, okay? So these two are factors for a squared minus b squared. If you have never experienced it, please go ahead and multiply the two brackets. You'll be able to get this, whereby we multiply the first term times the second bracket, then the second term times the second bracket. When you simplify, you'll be able to get this. So our first step in making A to be the subject is going to be C is equal to A squared out of A squared minus B squared. I have simplified, I have substituted this with A squared minus B squared. Now that A is up and down in the denominator, that means now I need to put this out of 1 so that I can cross multiply. But as I think of cross multiplying, I say I have more than one term, then the best thing is to put brackets. Then we can go ahead and cross multiply. So we have C into A squared minus B squared is equal to A squared, right? We can go ahead and open brackets. C A squared minus C B squared is equal to A squared. Fine. Now I say I have a term with A squared on this side of the equation, and I also have it on this side, okay? But this term has no A, and since I'm interested in A, then the best thing is to have A terms on the left hand side. So what do? I will move this A term, A squared term, to this side, and I also take this term to this other side so that I can write C A squared. Now this term becomes minus A squared is equal to, this term turns into a positive CB squared, okay? Someone would think of moving this to this side. Fine, that can also work, okay? But for today, let me follow this. So now I have A squared and A squared becoming common, and since I'm interested in it, I'll factorize it out. So I say A squared into C minus 1. Are you okay with that? A squared times C, C A squared, or what you can say A squared C. When we say 2 times 3, this is the same as 3 times 2. So when I write C A squared, it's the same as A squared C. Okay, then A squared times minus 1, I get minus A squared. This is equal to CB squared, right? And from that, since this is a multiplication, I can divide on both sides by C minus 1. I also divide on this side by C minus 1, right? Now this bracket will disappear, and after that I can write A squared is equal to cb squared out of c minus 1. Are we good with that? Then the only thing I need to do is to put away the square here, this power 2 here. And how do we put it away? When we take square root on both sides. So that means a is equal to square root of, I can even now introduce brackets here so that I show that I'm taking the square root of cb squared out of c minus 1. Okay, so when you take square root on both sides, at this step here, when you take square root, this square root cancels this square, so I can comfortably write an a. So I've been able to have a left on one side, and so I have made a to be the subject in that equation. Nice. Let's move to question 2. He's here. Question 2 is here, and we are told to make b the subject of this equation here. Fine. So when I look at my equation, I say I have a t term, I have a 20 plus square root of this, and b is somewhere here under the square root. Okay, now given this has no b, I can do that as my first step. I can move this to this side so that I write t minus, now that 20 becomes minus because it is crossing equal signs, is equal to square root of a minus b squared. Okay, fine. What should I do next? I have my b under the square root sign, and I need now to remove the square root sign, and that can be done if I square both sides of the equation. What I do on the left hand side is what I do on the right hand side, and when I square, this will put away the square root. So I will write t minus 20 squared is equal to a minus b squared. Now the question is telling us to make b the subject. We do not need to waste time expanding this. Okay, we shall have it the way it is. We do not need to expand it. So let us focus on our b. When I look at my b term here, which is b squared, I have a minus sign in front of it. Okay, do you see that minus sign? But remember, I need it when it is positive because the question says make b. So now, instead of moving this a to this side, the best thing to do is I'll move this term to this side so that it turns to be positive. And when I do that, at the same time I'll move this term to this other side. So I can comfortably write b squared, when it crosses equal sign becomes positive, is equal to, here I have stayed with a, and now this term on this side being positive, remember when we write a term without a sign, it means it is a positive term. So now when it crosses equal signs, it becomes minus t minus 20 squared. All right, we do not need to waste time expanding this. Fine. And now when I look at my b, it is squared, I need to remove the square. Okay, and how do we remove the square? By taking the square root. Do you see that? By taking the square root on both sides. Okay, now the square root is for both sides, not just a part. I can even put now this in a bigger bracket to show that, oh, I'm taking the square root after simplifying. Sorry about that. After simplifying. Okay, so I'm putting a big bracket like this. So we are not taking square root for this part, but I'm taking the square root for the right hand side, the way I have put it in a bigger bracket. So I can put away this, and I write b is equal to square root, let me put my big bracket, of a minus t minus 20 squared, and I have it like that. Okay, so we have been able to have b left on one side, and that means b is now the subject of that equation. Question number 3. We have this n is equal to x. Please note that x is a part here, it's not here. The moment you write it up here, then it means something different. It is a whole part here, then times square root of this, and this is in brackets. And what do we need? We need to express m in terms of n and x. Okay, So still that means we need to have m left on one side, whereas terms n and x are on the other side. So we want to make m to be the subject. So looking at this given equation, what should be the first step? When we look at this x, it has no m, we don't have m on this side. So we can decide to divide on both sides by x. So our first step can be n out of x, when I divide by x on both sides, is equal to square root of 2 out of 4m squared minus 1. Okay, so I've simply divided by x, so here it has turned into a 1. I have it on this side. Fine. Then when I look at my m, it is under the square root. So how do I get it? So that means I need to square the two sides. So when I square on this side, I need to square everything, so I'm putting brackets. I also square on the right hand. I square on the right hand side so that I can put away the square root. And now this means I have n squared out of x squared, because the power applies to the numerator and to the denominator, is equal to now 2 out of 4 m squared minus a 1. Okay, now m is down here, we need to move it up, and the only way to move it up is when we cross multiply. So our cross multiplication step, n squared into 4m squared minus 1 is equal to 2x squared. Fine. Then at this point, since this has no m, I can decide to divide on both sides by n squared. Okay, I can think of that. But when I look at m, I still see that it has 4. So if I do that, that means again I'll need to divide by 4 somewhere, and then my statement might not look nice. Okay, so to avoid that, instead of dividing by n at this step, I want to open brackets. Okay, so that I'll write 4n m squared n. You can write n squared m squared, no problem, it's the same thing, minus, when I multiply this by this, I get n squared is equal to 2x squared. Okay, and now I can move this minus n squared term to this side, so that I write 4m squared n squared is equal to 2x squared. Now it turns into a positive n squared. Okay, fine. Now that we have this, when we divide on both sides by 4n squared, I stay with m squared is equal to 2x squared plus n squared out of 4n squared. Okay, I've simply decided to divide here by 4m squared. I've also divided here by 4m squared. So this will disappear. Sorry, this is by n squared, not m, n squared. So that I put away n squared again, and I can stay with my m. Remember, we are interested in the m. And after that, since my m is squared, then I need to take the square root on both sides. And then the best thing to do is to have everything in brackets, so that I show that I'm taking the square root of everything here. This will put away the square, and so m is equal to this square root of 2x squared plus n squared out of 4n squared. We can have it in brackets. So that is our final answer. We have been able to make m to be the subject, which is also known as expressing m in terms of x and n. Good. Let's continue with our question 4. Question 4, she's here, and she says, given that a is equal to 2 pi square root of c out of b, express b in terms of a, pi, and c. Okay, that's the first part. And then it says, find the value of b if c is that, pi is that, and a is equal to that. All right, so we need to have b left on one side of the equation. when we look at this term here, it has no b, so our first step can be divide on both sides by 2 pi. That's why I'm writing a out of 2 pi is equal to square root of c out of b. I don't need to copy the question again, so I go straight with my first step. Divide on both sides by 2 pi. I have a out of 2 pi is equal to that. Is that okay? Okay. Now, I have b under the square root sign, and I need to move it out. And the only way I can do that is by squaring. So what I do on this side, I also do it on this side. Okay? And since this is a fraction, that means when you remove brackets, we get a squared, okay, out of 2 will also be squared, so it turns into a 4. And then since this is multiplication, pi will also be squared, so we have 4 pi squared. Have you seen that? The square squares this a, we get this same square squares the denominator, so that 2 becomes a 4, and then pi also turns into pi squared. So this square is now on the pi. Okay, this is equal to, this helps us to put either square root sign c out of b. Now that our b is in the denominator, we need to move it up, and then we need to cross multiply. So that means I can write ba squared is equal to, when I multiply this by this, we write 4 pi squared c. Please, we can't write c 4 pi squared. We start with the numbers, and then the letter comes last. So if I want to say 4c, I write it like this, and not this. This is not okay, unless you have c times 4, but you can't write c4 like that. Okay. Now from here, I just need a b left on one side, so I can divide on both sides by a squared. I also divide here by a squared. This will go off, and so I'll write my b as 4 pi squared c out of a squared. So we have been able to make b to be the subject, and after that we can continue with the next part of the question, where we are supposed to substitute values of c. So I have b is equal to 4 now times the pi I've been told to use is 3.14, then it is squared. Please do not use 22 out of 7. The instruction is here that use this. Then times c, which is 240. This should be divided by 12.56 squared. Okay. And now we need to use our calculators. And when you multiply this, you simply ask Mr. Calculator to do this for you. You'll be able to get a value like this. You can test it and then put it right if mine is not okay. Then when you square this, you get a value like this. Please, when we are working out, there is no need for you to round off these values. They are just nice. Leave them the way they are. And when you divide, you comfortably get a nice answer, which is 60 there. Okay, so that is our value of b. Okay, fine. Question 5. We have been given this 4 to power x. I hope you're able to see the powers. 2 to power y. It is not 2y, it is a small number up here. And then we also have a number in the denominator, 2 to power p. And we are told to express p in terms of x and y. So we are supposed to make p to be the subject. Okay. Now when you look at this given equation here, you see we have a base here 4, a base here 2, a base here 2, and a base here 2. Okay. So that shows us that there is something common to these other 3 parts. And so we can also think of writing this as 2 to power 2, okay, but since it has another power here, so that means we're going to write 2 to power 2x. Okay, when a number has a power and another power, these 2 powers can be multiplied. Then times 2 to power y out of 2 to the power x plus 2y is equal to 2 to the power p. So we need to use some rules of indices, okay? What do we do when we are multiplying numbers with the same base? The base is 2. We need to add the 2 powers, so I can write 2 to the power 2x plus y out of 2 to the power x plus 2y is equal to 2 to the power p. Okay, are we there? Okay, then the same base in the numerator and denominator. What do we do when we are dividing numbers with the same base? We need to subtract the powers. But now you need to be smart here, because you have a power which has 2 terms. Then when you are subtracting, the best thing to do is to put brackets, okay? To put brackets, okay, that I'm subtracting this power here, okay? This is equal to 2 to the power p. Now from there, I see that I have an equation. The base here is 2, the base here is also 2, and since the same base, that tells me that even these 2 powers should be what? Should be the same, okay? 2 to the power number, everything put together will give us a number, 2 to the power p. So that means this p should equal to this number here, right? So I can write p is equal to 2x plus y. Then see how I open brackets, x becomes minus, then 2y also becomes minus. That's the reason why I introduced the brackets, to see how the signs on these terms here will change. And now when I put like terms together, let me write my answer up here. Forgive me for being a little bit disorganized. P is equal to, when I take away 1x, I stay with x, and then 1 take away 2, that means we have minus y, okay? And by doing that, we have been able to write p in terms of x and y. We have made p to be the subject. I hope you enjoyed that. Our last question of the day, question 6. It says make q the subject of the expression. Okay, the language is not nice. Of the equation, because we have equal signs. Of the equation, and this is the equation, all right? And now when I look at the given equation, I have q up and q down, okay? So that means somewhere I need to put those terms together, and then I can continue to make the q to be the subject. What should be our first step? We are going to cross multiply. So I want to write, when I cross multiply this times this, I want to write y into p plus 3q, okay? I'm putting brackets because I have more than one term, is equal to, then I also write x into this lower term here, q minus 3p. There. From there we can now open brackets, this times this, py, this times this, plus 3yq is equal to xq, when we multiply by this, minus 3xp. Okay, now we are interested in the q terms to be left on one side. Then I'll take this to this side, I'll move this to the other side. Okay, so I can write my 3yq. When this term crosses equal signs, it becomes minus xq is equal to, now here I have stayed with minus 3xp, okay? This term here is a negative term. Then also this term, when it crosses equal signs, it becomes minus py. All right, then when I look at this step, I see that q and q is common, and it's what I'm interested in. So that means I can factorize it out, and I write 3y minus x, okay? The brackets simply say I will need to multiply this by this. I go back to this times this, I get this. This is equal to Do I need to simplify this side? No, I do not need to waste time with this. I'll write it the way it is. They are non-like terms, I cannot simplify them. And so from here, when I divide on both sides by this term here, let me go ahead and I divide it. I want to write this bracket down here, and I also do the same thing on the right hand side, okay? So that I put this term away, then my q is equal to minus 3xp minus py out of 3y minus x. And so I've been able to make q to be the subject. All right, now depending on how you moved your two terms here, okay, at this step, remember for me, I decided to move this term to this side. Another person will decide to move this term to this side, so that now they take this to this side. So your answer might look like this one here. Do not be scared if this is the answer that you have, okay? Like that one there. That one is still okay. When you look at this answer, it's like if I multiply the numerator by negative sign and I multiply the denominator by negative sign. So this answer is also very okay. Actually, it's the same. Okay, it's the same. Thank you for going through this. I encourage you to practice, perform. Practice, perfect, and then you can perform. Thank you.